Alright, here we find ourselves in section 9.2, and it really is the same concept, it's just with the means. And so you can see I've already have StatCrunch opened up on the side, and so we're going to utilize that. Now this very first question is asking about our understanding of a confidence interval. So let's go ahead and read it. It says large samples of women and men are obtained and the hemoglobin level is measured in each subject. Here is the 95% confidence interval for the difference of the two population means, which measures from where the measures from women corresponding to population 1 and the measures from men correspond to population number 2. So when they did women's minus men, the result was negative. That means the man is higher. And notice that the whole range is negative. Complete parts A through C. What does the confidence interval suggest about the equality of men hemoglobin level in the equality of the mean hemoglobin level in women and the mean hemoglobin in men? Well, notice that the subtraction is bound between two negative numbers. So because the confidence interval does not include 0, so they're having us type it in now, right? But it's the same idea that was there in 2. 0 is the most important thing because 0 is where the two are equal. It doesn't include 0. So it appears that there is not a significant difference. I'm sorry, there is, right? Because it doesn't include 0, there is a significant difference between the mean hemoglobin men and women. And because if 0 is in the interval, then they could be the same. But because 0 is out of the interval, we know one's bigger than the other, or they're different. Write a brief statement that interprets the confidence interval. There is 95% confidence that the interval between negative 1.6 and negative 1.62 does not contain the value. Okay, that's weird. It should contain the value. Contains the value of the difference. Yes, that's what the confidence interval does. It's 95% confident that the actual subtraction is going to be in there. Express the confidence interval measures from men being in population 1. So if we switched it from men and women, all that would change is the sign. And so there's going to be positive. And it's going to be this guy right here, positive 1.62 to 1.76. Take a look at the original, I don't know if I can highlight it, I don't think it lets me, but take a look at this original one where my cursor is, the negative 1.76 to negative 1.62. That meant that men were higher by 1.76 as much or as little as 1.62, but more than 1.62 but less than 1.76. If we do men minus women, the answer should be the same numbers but only positive. So they're just making sure we understand what's going on with this question. And so again, let me just click this off so it doesn't immediately go to the next question. This is telling us that there's a difference, and whoever is second is bigger, has the bigger mean. The second one was the men. Here the men are first, so if I do the bigger one minus the smaller one, I should have the same difference, but it would be positive. So it's this guy right here. Let's go look at question number 2. Question number 2 is going to be similar to questions 2 through 8, really. And so we'll look at 2 and we'll also look at 3. So if we read through here, it says data on the weights on the contents of cans of diet soda versus the contents of cans of regular soda are summarized in the table to the right. Assume that the two samples are independent, simple random samples selected from normally distributed populations, and do not assume that the population standard deviations are equal. So let me explain some things there. What they're assuring right there is that we can use the t-test. We would use a z if the population standard deviations were equal. That won't be the case in any of these problems. At least not that I think in there. Where it's definitely a t-test. And we're going to complete parts A through B below. Now what's the claim? The claim is there in A. Test the claim that the contents of the can of diet soda have weights with the mean that is less than the mean for regular soda. Okay, so they let the diet soda be number 1. That's good because that's what they mentioned first. And they want it to be less than. So I'm going to look at all my alternate hypotheses and look for a less than, and there's 2. Only one of which has the appropriate null hypothesis. Because the null hypothesis has to be equal, we'll check our answer. Now we have really a nice thing here in StatCrunch. We're going to go over to Stat, and this is a t-statistics. Okay, so the mean has always been associated with the t-score. So it's a 2-sample, and we have the data summarized. We don't have the individual 39 pieces of data. We have it all simplified, or summarized is the best word to say there. So as you look at this, make sure you're filling in the right numbers to the right box. Box number 1 isn't the top number in our box. Box number 1 for StatCrunch is the sample mean, which for the first sample, which is this first column here, is, and we type it all in, 0.779338. And I don't think you have to do the 0 point. Standard deviation is 0.00431, and the sample size is 39. Sample 2. The mean there is 0.81618. The standard deviation is 0.00753. And the sample size is 39. Now, you'll never click this next one, the pooled variances one. You'll leave unchecked, but we're going to perform a hypothesis test. That's what we're doing right here in part A. We need a test statistic. So mu1 minus mu2 is equal to 0 is always going to be the case, and now we have to choose the correct number symbol here, and it's whatever the symbol in our alternative hypothesis is. Again, if you were to solve this for m1 or mu1, you'd add over mu2 and have mu1 is less than mu2. That's exactly what we have here in our alternative hypothesis. You're ready to compute. And when you compute, the numbers that you need are here. So what's the t-statistic? The test statistic, it's right here, negative 16.41. It wants us to round to 2 decimal places. And we check that. Fantastic. Pretty exciting. P-value right next to that. Now, you knew you were going to get a pretty low p-value if your t-test statistic is already negative 16.41. That represents the number of standard deviations, and that's a long ways to be away. So rounded to 3 decimal places should be 0.000, right? I would take that 1 and leave the 0 alone. And it's going to say, hey, that's great. Good job. So what do we do whenever our p-value, which is pretty much nothing, is less than our significance level, 0.05? Well, whenever your p-value is less than your significance level, you reject. And when you reject, you always have sufficient data. So I'm looking for a rejection and the word sufficient data. And here's the word rejection in C, but not sufficient data. That's not us. Rejection means sufficient data, sufficient evidence. And we check that answer. And we say, okay. Now guess what's going to be here? You're not shocked. It's going to be the confidence interval. So remember, this was a one-tailed test. Why was it one-tailed? Let's see if I can highlight this. It's one-tailed because of the less than sign right there. A greater than is one-tailed, a less than is one-tailed. Because it's one-tailed and confidence intervals are two-tailed, we need to double our significance level so that the confidence level matches. So remember what we're going to do. We have that data stored. So we're going to go Options, Edit. It's very similar to what we did in 9.1. And instead of hypothesis test, we're going to do a confidence interval, but not for 95, but for 90% confidence. Again, why 90%? Because the 0.05 needs to be doubled because it was a one-tailed test. And so we get a nice 90% confidence, and we're going to compute. And that's what they mean by using the confidence interval appropriate for the hypothesis test. That's what's yielding the 90%. And so now I just have to put in the two limits. Now we're not shocked to see that they're both on the same side as 0. That's what led to us rejecting, knowing that they weren't equal to one another. And they want us to go out 3 decimal places, I think. Oops, so that would be just 0.025. And this one would be 0.020. But negative. I almost made a mistake there. Would have gotten off. Whoops. Let me just go over that whole thing and let you see what I'm typing in there. Negative 0.205. Whoops. Even that's wrong. 0.0204. Okay, so 0.020. And then we'll check that answer. Again, I'm getting those from right here. Those are your upper and lower limits. And we're going to check that answer. It should come up just fine. Okay, that's not, I had a communication error because of my internet access. Let's see what happens here. Good job. Got me scared again. Then we did something right. Now, take a look at that interval. Remember the question you're always asking yourself. Does the interval include 0? Because if it does, it means the two things can be equal to one another. In this case, the two volumes. But, or two weights, apologize. The two weights could be equal. In this case, that 0 is not in the interval, which means we know that there's a difference between the two. Does the confidence interval support the conclusion? Absolutely it supports it. Yes, that's going to be the case because it contains only negative values. If it contains only negative values, then it doesn't contain 0. And if it doesn't contain 0, then you can reject your null hypothesis. And we're finished with this problem, maybe? Let's see if it... Let me move my computer, see if it catches the internet better. There we go. Excellent. And we get to the next question. So we'll do one more because my promise to you is that they're all going to be alike. So here we are in number 3. In number 3, we got a brand new set of data. This one is about a treatment group and a placebo group. And the claim is that the two samples are from populations with the same mean. Okay, so that the treatment group is equal to the mean of the placebo group. Well, if it's equal to, that means our null hypothesis and the claim are the same, so my alternative hypothesis will be the not equal to. So I'm looking for a not equal to alternative hypothesis. I just found it. And we say nice work, and we're moving forward. So now we're going to close this one out, but we're going to come over here with our new data because it's going to ask for a test statistic. So again, we go to stats. This is a t-test statistic. T, 2 samples. And we have it summarized. Sample mean. So let's go plug in the sample mean for the first sample. 2.36. Sample standard deviation, 0.87. Sample size, 30. Sample mean, 2.63. Sample standard deviation, 0.57. Sample size 36, and we're just careful that we are grabbing the right numbers, putting the right decimal points in it. Take your time through this. Now the null hypothesis is always going to be mu1 minus mu2 is equal to 0 in StatCrunch, and then the symbol for the alternative hypothesis must match the symbol that we have. In this case it already is done, so we're ready to compute. And when we compute, we get a t-test statistic of negative 1.45. Actually 1.46, right? Because it would round up. And we check that. Fantastic. P-value written right next to that. 0.151, right? 11, but it wants me to stop at the third one, so I look at the fourth decimal place. So I'm looking here at the p-value. And out to the third decimal place, it should be 0.151. And we'll check that answer. And then what does that mean? So we got P being 0.15. Guess I don't need to scroll down. A significance level of 0.01. Well, that's not less than it. So if the p-value is not less than the significance level, then you're going to fail to reject. So I'm looking for a fail to reject. And remember that fail to reject always means not sufficient data. So the only one that says fail to reject and not sufficient is the first one. Or sorry, the first option, but letter B. Construct the confidence interval. So remember, this was a two-tailed test. So construct the confidence interval suitable for the claim. The claim was a two-tailed claim. That means that the 0.01 does not have to be adjusted because confidence intervals are two-tailed. The test was two-tailed, we match. So all we have to do is edit, come back and choose confidence interval, and it's going to be a 99% confidence interval. I do not have to adjust the 0.01 because part A was a two-tailed test. Why was part A a two-tailed test? Because it was a not equal to null hypothesis. This, or alternative hypothesis. This alternative hypothesis right here allows me to know that it's two-tailed. A is a one-tailed. B is a one-tailed. C is a two-tailed, right? Anytime it's not equal to. Because the test matched what a confidence interval always is. A confidence interval is always two-tailed. We don't need to adjust. Hopefully that's making sense to you. And so what do we have? Our lower limit rounded to 3 decimal places is negative 0.766. Our upper limit is positive 0.226. And it says great. Now that agrees actually. Oh, that's all they want. So that actually agreed. I can go back, sorry. I was going to say if I knew that I was clicking on to the next question, I would have hesitated. Notice that it contains 0. Mu1 minus mu2 could be 0. Because mu1 minus mu2 could be 0, you cannot reject that they're the same. If two things are the same and you subtract them, you get 0. So because that's a potential, mu1 could equal mu2, and that's why we're not rejecting it, because our data doesn't support strongly that that should be rejected. They are different from one another, but they're not that different. And so as we look at all these problems, they're all going to be the same. Let me just go look at what number 8 has. Yeah, it's the same. In fact, almost the exact same numbers as an earlier one, right? The one we just did. So it's just going to be repeated over and over. This is how to use StatCrunch to really use your time effectively. So I'm grateful that you have this tool available to you and encourage you to use it. Again, we have to use it in the 9.2 section because our t-chart's not robust enough to give us the p-values that it sometimes will need. All right, thanks for watching this, and I hope it's very much, I hope that it helps a lot.